late. I apologize. I got stuck in traffic a little bit before I could get home.
That's all right.
Okay. Looks like you got these first four, correct? Do you have any questions about any of those?
No.
Okay. You know that the negative sign makes it go upside down, and that this is a vertical shift. It looks like that's clear to you. The coefficient in front of the x squared makes it skinnier. In other words, this coefficient 3 for this graph here, notice that that parabola is skinnier than this one over here.
Okay.
Okay. Find the coordinates of the vertex of the graph and each function. So for 5, how do you find the vertex of the graph?
I have no idea.
Okay, well there's a couple of methods. Let's go over and figure out which ones you've been taught. There is the method of finding the x-coordinate first. In other words, the vertex x-coordinate is equal to minus b over 2a. Does that look familiar?
No.
That's the first half of the quadratic formula. Remember the quadratic formula?
Yeah.
Plus or minus the square root of b squared minus 4ac. Well, that's the first part of it. So use the quadratic to memorize this, or use this to help memorize the quadratic. But they go together. Okay?
Okay.
So in this equation, what is A and what is B? Remember that this is the standard format right here. There's your A, B, and C. Minus 4 is A.
Yeah.
What's B?
Positive 3.
That's C.
Oh. 0?
Yeah. So what is the x-coordinate of the vertex? What's negative 0 divided by negative 8?
0.
If 0 is in the numerator, the answer is 0.
Yeah.
Doesn't matter what's in the denominator, at least not at this level. At higher calculus, if 0 is in the denominator, then you got a problem. If you got 0 divided by 0, that's actually indeterminate. You can't figure out what that is without calculus. But if we have 0 divided by any number, it's always 0. So the x-coordinate equals 0. So what does the y-coordinate equal? Here is our function. If the x-coordinate is 0, how are you going to figure out what y is? Use this function right here.
So you put in x.
Equals 0. So what is y equal to when x equals 0?
Positive 3.
You got it. So there's your vertex right there. X equals 0, y equals 3. Meaning if I'm going to plot this thing, if I can find the vertex, that's 90% of the problem, right?
Yeah.
Well, where's the vertex? 0, 3, right there. I know from the negative sign that it goes downwards, so it looks a lot like that. So once you can find the vertex, the rest is pretty easy. I mean, I didn't figure out the x-intercepts, so I didn't plot it as accurately as I could have, but I know a lot about this parabola. I know the vertex is there, and I know it goes down.
Right.
Okay. Now, they did say, no, just find the coordinates of the vertex of the graph of each function. All right. Well, they didn't really ask us to graph it. If they would have asked us to graph it, I would have started there. I know it goes down, but I kind of need these 2 points here, right? I need to know where it goes through the x-axis. And how I would solve that is set that equal to 0, because y is 0 when it goes through the x-axis, and solve that equation. In other words, make that 0 and solve that equation, and that will give you the 2 values of x where it crosses the x-axis. And then you can graph it. Any 3 points graph a parabola, and the best 3 points are the coordinates of the vertex and the 2 x-intercepts, if there are x-intercepts. There don't have to be x-intercepts. In other words, I can have a parabola like this, but they're not going to give you those yet.
Okay.
Okay, notice that doesn't have any x-intercepts. So there is no place where y is equal to 0. All right, let's look at the, let me erase everything here but that. Have you been taught how to complete the square? Or I should say, have you been taught how to put these into vertex format?
No.
Not yet? Is it coming,
No.
do you know?
Maybe.
I don't want to teach it to you unless you're going to get it. And I'm not positive you're going to get it. You can always use the method I just used to find the coordinates of the vertex. Let's use that same method on number 6. And it doesn't involve factoring like you are starting to do that. That will actually put it in a format, but it doesn't give you the vertex. It doesn't tell you much, but it tells you the x-intercepts. Okay?
Yeah.
In other words, if you were to factor this quadratic and you get x minus, well, it doesn't even factor nicely, does it? No, it doesn't factor nicely at all. I would need factors of 12 that subtract a 5, and there aren't any. 6 and 2 don't do it. So, we don't want to do it that way anyway. I want to use this method, and I want to use this. What's the formula for the x-coordinate of the vertex?
A squared over 2a.
No, it's the first half of the quadratic.
Minus b squared.
Just b.
Oh, just b.
Remember,
Over 2a.
Here's the quadratic. Let's review all of these. What's the first half?
Minus b over 2a.
That's the x-coordinate of the vertex. So for this equation, they've got it in standard form. What's a?
X squared.
No, it's the coefficient of x squared.
Oh, x?
It's the coefficient of x squared. It's 1.
1.
It's not written, but when it's not written, you note it to be 1.
Yeah.
So a is 1. And incidentally, that a is the same as that a, even though I use a capital there and a small letter a there. I don't know why I do that. Let me change it. Let's put it properly. It should be a plus b plus c, like that. What's b?
5.
Notice that we don't need c. C's not anywhere in that. So what's minus b over 2a?
Negative 5. Oh, hold up, my screen went black. Negative 5 over 2.
There's your x value. Now, that's something else other than just your x value. if I go to that point, that's minus 2.5. Let's call that minus 2.5. Okay. Not only is that the x-coordinate of the vertex, but that's something else that they call the line of symmetry. In other words, my parabola that I end up drawing here has to be symmetrical with that line of symmetry. It has to look the same on the left as it looks on the right of it. And how do we get the y-coordinate? Because I know that this parabola lines up along that line of symmetry, but at this point I don't know whether the vertex is down here or up there. And I don't know yet whether it goes up or down, although I do know that. I can see it goes up. But I don't know where the y-coordinate is yet. How do I get the y-coordinate?
You have to put in -5/2 for x, right?
Okay, so tell me what y is exactly. Tell me how to write it. What's the first step? Don't give me the answer. Just give me the first thing you would do if you were solving this.
So I'd be like,
X equals minus 5/2. Okay, so there's your function right there. X squared plus 5x minus 12.
yeah. So, I don't think I know what to do.
Substitute minus 5/2 wherever you see x.
Okay.
But it's very important to use parentheses because it's a negative 5/2. So that's what I was trying to get at, was to see whether you put the parentheses in. Because this is not the same as that. When I square this, I'm squaring the 5 and I'm squaring the 2, but I'm not squaring the negative sign. So this thing here is going to be equal to minus 25/4. Up here, when I square it, the negative times a negative becomes positive. So this whole thing is 25/4, positive 25/4. That's why these parentheses are so important. So let's finish writing it. Plus 5x. How am I going to write that?
Plus 5. Oh, parentheses, -5/2 squared.
Not squared. This one isn't squared. This is 5x.
Oh, yeah.
Okay? Minus 12. So that's the first step in figuring out y. Now let's do the exponentiating and remove all parentheses. So what's this equal to?
-5/2.
We're squaring it. So if I have a -5/2 times a -5/2, what's that equal to? How do you multiply fractions?
Do you cross multiply?
No? You multiply numerators and you multiply denominators.
Oh, so -25/4.
But negative times negative is what?
Oh, positive.
So it's 25/4. We'll leave it like that for a moment. How do I handle this part here? How do you multiply a fraction by a whole number?
I don't know.
Just multiply the numerators. In other words, that's the same as 5/1. And if I was multiplying 5/1 times minus 5/2, I would multiply numerators, multiply denominators.
-25/2.
And it's minus because I have this plus, but I got that minus. And when you have a minus and a plus, it's minus.
Yeah.
When you're multiplying. Minus 12. Now how do I get an answer for this?
You combine like terms.
How about let's find a least common denominator. we're adding we're subtracting two fractions here that have different denominators. You can't add or subtract fractions that have different denominators. You got to find a common denominator. So what's the least common denominator between 4, 2, and 1?
2. Or wait, no, 1.
4.
Oh, 4.
Remember that every term has to divide evenly into your least common denominator. So if my least common denominator is 4, that works because 4 divides into 4 evenly, 2 divides into 4 evenly, and 1 divides into 4 evenly.
Yeah.
Notice that if I were to use a 2, 4 does not divide into 2.
Yeah.
So I can't use 2. I have to use at least the biggest number. Sometimes that's not even enough. In this case, 4 works. So what goes there? What goes there and what goes there? What goes there? That's what it started out as. Still has 4 as its denominator. What's its numerator have to be? We're not changing the number.
What do you mean we're 25? Oh.
If I put any other number other than 25 there, I've changed the number. In other words, there's no way 21/4 can equal 25/4. And remember, when I'm trying to add or subtract these fractions, I'm not changing any of these numbers. I'm just stating them differently. 25/4 is 6 1/4. That's 6 1/4. 25 halves is not 25/4. What goes here?
20, oh.
Take this, divide it into this, and multiply it by that. That's always what goes there.
50?
Notice that 50/4 is the same number as 25 halves.
Yeah.
And that's how it should be. I don't want to change that number. I just want to give it a denominator of 4. So what goes here?
48.
Good. Now that I have a common denominator, I act only on the numerators. There's the common denominator answer. So now what is 25 minus 50 minus 48? You can use your calculator if you need to.
Minus 97.
But if you're going to use your calculator, make sure you do it right. Do 25 minus 50 minus 48 equals?
Oh, minus 73.
Minus 73 over 4. In other words, my common denominator just gets carried forward all the way to the end. So x was minus 5 halves. Y is minus 73/4, and I can't reduce that at all. 73 is not divisible by 2, it's not divisible by 4. So let's graph this.
Okay.
So where is my vertex? Tell me how to find my vertex. First of all, let me help by drawing the line of symmetry. I'm going to make that minus 2, that minus 3. So the line of symmetry goes right down through minus 2.5. Remember, that is not only the x-coordinate of the vertex, but it's the line of symmetry. So where's my vertex now? If this is quadrant 1, 2, 3, and 4, where's my vertex in which quadrant?
2.
It's negative 73/4.
Oh, so quadrant 4?
3.
Oh.
In other words, I'm already to the left of the y-axis because my x value is negative, right?
Yeah.
Well, in quadrant 4, all the x values are positive. So it's the same with quadrant 1. In quadrants 2 and 3, the x value is negative. In quadrant 3, both are negative. So my y-coordinate is somewhere down there. The coordinate of that vertex is minus 5/2, comma, minus 73/4. That's the label that goes on that point right there. Now, graphing it. Now, let me show you a little easier way to graph it. Last time we graphed it, I found the x-intercepts, right?
Yeah.
That's going to be hard to do on this. You have a good start there. The problem is that quadratic does not factor. And if I want to find the x-intercepts, I'm going to have to use the quadratic formula. That's going to give me a lot more math and a lot more chance to make a mistake. So, instead of finding the x-coordinate, let's find the y-intercept. The y-intercept is easy. That's where x equals 0. Well, what does y equal to when x equals 0?
0.
Plug it in. Look at the function. Plug in x equals 0. What's left?
Negative 12.
Yes, that's the y-intercept. Always with quadratics, that's the y-intercept. Because the y-intercept is by definition where x equals 0. Well, x equals 0 eliminates both of these terms. So you're always going to be left with your constant. So minus 12 right there. I know that the curve has to go through that point there, like that. What else do I know? I know that it's symmetrical, about that line of symmetry. So I know that that minus 12 has to exist somewhere right there also. What is the x-coordinate on this point? I know what the x-coordinate on this point is. It's 0. But the x-coordinate on this point is not 0. Y-coordinate is minus 12. What is the x-coordinate on that? How far away is this x that I've drawn from that line of symmetry?
I think just minus 1.
2.5. Remember, the line of symmetry was at minus 5/2?
Oh, yeah.
So I'm 5/2 away from the y-axis. Well, because this is symmetrical, I must be 5/2 away from on the other side also. So if this line is minus 5/2 and I'm 5/2 further this way, what's that point going to be?
Minus 5.
Yeah. Now do you see why? In other words, minus 5 says that we're 5 units away from the y-axis, right?
Yeah.
Well, I know that this is 2.5, and I know that this is 2.5. That's what I mean by symmetrical, is this line of symmetry splits those 2 points equally. So I figured out that the y-intercept was 2.5 away from that line of symmetry, so the other symmetrical point on the parabola has to be 2.5 the other way. And the full parabola can now be plotted because, like I said, you only need 3 points. You don't need x-intercepts. You just need 3 points to define a parabola. Those are the 3 points. That one, which is the vertex. That one, which is the y-intercept. And once we found the y-intercept, we can find its equal, opposite, symmetrical point, that one. Now, I don't know about you, but this was an easier way to do it than to plug that thing into the quadratic formula and come up with the 2 points that would be where it would cross the x-axis. That's a hard one. Only because they made the numbers so weird. I don't know why they do that. I don't think it really helps people. Just makes them challenged based on the math. What is the vertex x-coordinate?
3/2.
What's the general formula for it in terms of A and B?
Oh. 3.
Okay, we've been through 3 problems now where we've asked the same exact question. What is the x-coordinate of the vertex? It's the first half of the quadratic formula.
Minus b/2a.
That's the general formula. When I say the general formula, that's what I mean.
Okay.
In this quadratic, what's A?
3/2.
What's B?
Minus 6.
Okay, so what is minus B over 2A?
Is it positive 6?
Over
6.
What's 2 times 3/2?
Over 6/2.
Which is?
3/1.
So the x-coordinate of the vertex is 3. In other words, x equals 3 for our vertex. We're looking for our vertex. So we need the y-coordinate of the vertex, and we'll have the vertex. How do I get the y-coordinate of the vertex?
Plug in x.
So tell me what to write.
3/2 parentheses 3.
Squared.
Yeah. Minus 6 parentheses 3 plus 5.
And I would recommend using the parentheses even if that x value is not negative. When the x value is negative, it's critical to use them. It's even critical here because we're not squaring the 3/2. We're only squaring the 3. So simplify. Let's do it one step at a time. You don't need to do the exponentiation and the multiplication at the same time. Or you could if you want. Doesn't matter.
9/2.
No, let's make sure we know how to do it. 3/2 times 9. In other words, 3 squared is 9.
Minus.
Well, I haven't really done much. The only thing I got rid of was the exponent. Now let's get rid of the parentheses. What's 3/2 times 9?
Is it 27/18?
No. 9 is 9 over 1.
27/2.
There you go. Okay. What's the next term?
18. Oh, minus 18.
And
plus 5.
Okay. Now how do we do this? How do we get an answer here? If it makes it a little bit easier if I combine both of those first. What's that combination? What's minus 18 plus 5?
Minus 13.
Okay, so I'm going to erase that and put minus 13. Now, there's two ways to do this problem. The last time we did this type of problem, we found a common denominator. Let's try that way. And then we'll do it the other way, and you can take your choice as to which way you'd like to use in the future. But if I'm going to use a common denominator, what's the common denominator going to be?
2.
What's this? What goes here?
27.
What goes here?
13.
Is 13 halves the same as 13?
No.
Then it can't be 13.
26.
There you go. In other words, remember what we did? We took the 1, divided it into 2, that's 2. 1 divided into 2 is 2, and multiplied that answer by 13. That's how we get that numerator. The key thing is to make sure that this fraction is the same as that number. 26 over 2 is the same as 13. So now what is our answer for y?
Y equals 1 over 2.
You got it. Now let's go back and do it a different way. What proper fraction is 27 over 2 equal to? That's an improper fraction. But if I want to turn it into a mixed number, what would it be?
I don't know.
Well, divide 2 into 27. Get 1.
2. 13.
With a remainder of 1.
Yeah, okay.
And that remainder of 1 is actually a remainder of 1 divided by this divisor. So it's a remainder of 1/2. So 27 over 2 is the same as 13.5. Well, that's a little easier to do than our common denominator process. What's 13.5 minus 13?
Just a half?
Has to be the same answer. Just because we did it a different way doesn't mean we're ever going to get a different answer. I was just trying to show you a different way to do it where you don't have to use common denominator. In other words, if you can turn that into a proper fraction, then it becomes pretty straightforward. 13.5 minus 13 is 13. So I'll let you decide when you want to use that. The typical way to do it is to use common denominator. For some reason, people have a real problem using a common denominator when one of the numbers is not a fraction. They don't recognize it as a least common denominator problem. Well, if that's a problem for you, then put 1 under it. Now it's a fraction, 13 over 1. Now it looks more like a problem where you have to use a least common denominator. See what I'm saying?
Yeah.
All right. So the x-coordinate of the vertex was 3. The y-coordinate of the vertex was 1/2. So let's try to graph that. 3, 1/2. First of all, we find that point. I go 3 units to the right on the x-axis, and 1/2 unit up on the y-axis. Right?
Mm-hmm.
Does this thing open up or down?
It goes up.
Aha! We're not going to have any x-intercepts. But we still need 3 points. There's our line of symmetry. We know that it looks something like that at the bottom, right?
Mm-hmm.
But we only have 1 point. We can't draw this parabola accurately until we have 2 more points. We don't have an x-intercept. We can't even solve for the x-intercept. So what's the best thing to solve for?
The y-intercept?
Which is what here?
Positive 5.
Beautiful. Right there. Positive 5. So I know this part of the parabola goes like this. Give me another point. Well, I know that there has to be another point up here at 5 on the y-axis, right? Question is, what's the x-coordinate of that point? Because we have to label all 3 of these points. This vertex is 3, 1/2. This point is 0, 5. What is this point right here? We know it's comma 5, right? We know the y-coordinate is 5. What's the x-coordinate?
I think 5.
Nope.
Is it 6?
Yeah. Notice that our line of symmetry is 3 units away from the y-axis. Right?
Yeah.
Well, it's got to be 3 more units away from this point. Those have to be equal because it's a line of symmetry. These points are symmetry. So this point right there has to be 3 units to the right of my line of symmetry, which means 6, because my line of symmetry is at x equal 3. So that was actually one of the few ways, that was definitely the easiest way to graph it. In other words, I didn't even have a choice there. I couldn't come up with x-intercepts if I wanted to do it that way.
Yeah.
Because there aren't any. But I could come up with a y-intercept. The y-intercept's the easiest thing to come up with. You just look at whatever the constant is, that's the y-intercept. The difficult part is figuring out the other point that goes with that y-intercept. In other words, there's always an opposite symmetrical point right there that is at the same y value, still at y equal 5, but the x value is different. All right. Okay.
Okay, A equals 1/4
What's B?
equals 8.
And what is C?
0.
Very good. So the vertex x-coordinates equals general formula,
Minus B over 2A.
specific answer,
Minus 8 over 2 over 4, yeah.
when you take 1/4 and you have 2 of them, you have 2/4.
Yeah.
So it's not just 1/4 plus 1/4 is equal to 2/4. It's 1/4 times 2 is equal to 2/4. 1/4 times 3 would be 3/4. In other words, you just multiply the numerators only. When you have a whole number times a fraction, when I'm doing this multiplication, I'm just going to multiply numerators across, 2/4, because this 2 has a 1 under it. So I'm really kind of multiplying denominators across also, but I don't do that because it's extra work unnecessarily. Just remember that when you have a whole number times a fraction, Just multiply the whole number times the numerator. Now, let's figure out how to solve that. How do you divide a number by a fraction? First of all, let's make it a little easier by changing that to 1/2. Still have to divide by a fraction, though. There's a rule that we use whenever we divide by a fraction. What do? We never actually divide by fractions. We do something else 100% of the time. We turn it into a multiplication problem. How do we do that?
Okay. You flip it.
So we flip the bottom only, and then we multiply. What's that?
Minus 16 over 1.
Just minus 16. You don't put the 1 in there. Only reason I put it in there was because I had flipped 1/2. So I wanted to make it clear that you saw that 2 over 1 was the reciprocal of 1/2.
Yeah, okay.
So the x-coordinate is equal to minus 16. What is the y-coordinate equal to?
1/4 parentheses minus 16 squared plus 8 parentheses minus 16.
You're a fast learner. Now let's simplify that.
Okay.
You have a calculator in front of you?
I have my phone.
Go ahead, and you're going to have to probably use it to square 16.
Is that 256?
Yeah. So what do I write right here?
1/4 parentheses 256
Plus or minus?
plus
Good. What do I write for the rest of it?
plus 128.
What about this minus 16?
Minus 128.
And what finally is 1/4 of 256? Or 256 divided by 4?
Is it 64?
And finally, what is 64 minus 128?
Minus 64?
So that is the vertex, the y-coordinate of the vertex. What was our x-coordinate? Minus 16. So minus 16 minus 64. Where does that go? Which quadrant? If this is 1, 2, 3, 4, which is the way, incidentally, they do label the quadrants. When you get to trigonometry, this is the way it goes counterclockwise like that.
The third one, right?
Yeah. What was it? X was minus 16, Y was minus 64. So let's make minus 16 right there on our grid. Minus 64 down here. So my vertex is right there, where that dot is.
Yeah.
Which method do you like for finding our other 2 points best?
The common denominator.
That's not one of them. One of them is to find the y-intercept. The other is to find the x-intercepts.
To find the y-intercept.
Okay, what's one y-intercept?
8.
Nope. What was C again?
0.
So there's the intercept right there.
Oh.
That allows me, let me draw my dotted line to represent the line of symmetry going through minus 16. And this part of the parabola is going to go right through there. So where does this point fall?
Positive 8?
Does it look like it's positive 8?
No.
What does it look like it is? If this is minus 16 right here, that dotted line is supposed to go through that.
So is that
What does that have to be? It has to be minus for sure.
minus like 24-ish?
How far, much further to the left of this line of symmetry do I have to go?
I think
The
16.
Yeah, the same distance as it is from the y-axis.
32.
You got it. So I've got my 3 points. The vertex is minus 16 comma minus 64. Another point is minus 32 comma 0, and a third point is 0 comma 0. In other words, there's our 3 points listed right there. It's better to list them on the graph. In other words, I wouldn't want to do it like this if I was taking a test. I would want to label the coordinates, just like you get it when you look at a test. So that's the vertex. That's minus 32 comma 0, and that's 0 comma 0. All right. You're getting the hang of these, I can tell. Now, have you and I talked about translations of functions? We have, haven't we? Vertical shifts, vertical stretches, horizontal shifts, horizontal stretches, reflections about the x-axis, and reflections about the y-axis. You and I just... Okay. So, to plot this function, y equals 2/3 x squared, we need to know what the elementary function is and what it looks like. So tell me what the elementary function is.
2/3
Nope.
x squared.
In other words, we're talking about a parabola. It goes through, the vertex goes through the origin, just like that. Only this is a parabola that has, it's exactly the same, only it's got a coefficient of 2/3 in front of the function. So what is my effect on this parabola? First of all, what is that? Is that a horizontal or vertical, and is it a stretch or shrink? It's not a reflection. Reflections require a minus sign somewhere.
It's vertical.
Is it a stretch or a shrink?
A stretch.
It's a shrink. Any number greater than 1 is a stretch. Any number less than 1 is a shrink, as long as we're talking the vertical. If we're talking horizontal, it's the opposite. Horizontal numbers greater than 1 are shrinks. Numbers between 0 and 1 are stretches. But this is vertical. It's completely away from that function. It's in front of x squared. It's not part of it. So it's a vertical shrink. Means every point has to come closer to the x-axis, right?
Yeah.
So am I looking at that, or am I looking at that? The skinny one or the fat one?
The skinnier one.
No. Notice that with the fat one, by this I mean the fat one,
Yeah.
Every point is closer to the x-axis. Instead of this point being right there, it's down there. And in fact, where it actually is 2/3 of the way. I didn't draw it very accurately. Let me try to draw it a little bit more accurate. Because that point needs to be 2/3. Do you get that concept? By 2/3, I mean whatever that distance is there. When I stick a 2/3 in front of that, that point is going to be closer. It's not going to be all the way up here. It's going to be 2/3 of the way. If it was half, it would be right there. In other words, what I'm saying is that this distance here is 2/3 of this distance there.
Right.
That makes it fatter, notice. In other words, if that point is below, every point is below, you end up with a parabola that looks like this when you connect the dots. So the parabola gets wider or fatter as the coefficient gets less than 1. Well, actually between 0 and 1. Okay? All right. We got time for another 1 or 2 problems here. Let's look at this function on 10. Again, what is our elementary function?
Minus x squared.
Just x squared.
Okay.
The minus sign is going to mean a reflection. Okay, so let me draw my elementary function, and then let's start translating it and reflecting it. We have 2 things affecting this that make it different than the elementary function. What are they? What's the consequences of that +3, and what's the consequences of that negative sign?
Well, one of them's a negative, one of them's a positive.
Well, there's more meaning than that. The meaning of the negative sign in front of the function means it gets reflected about the x-axis. So if I wanted to plot just y equal minus x squared, it would look like that. I would just take my elementary function. Because of the minus sign, I would flip it. You know what I mean by reflected over the x-axis?
Yeah, I think.
Well, if you take this and mirror it, it's the mirror image of the one that goes the other way.
Yeah.
That is what I'm doing when I'm reflecting this graph over the x-axis. It becomes this graph. So this function equals that graph. Now, there's one more thing that's being done to this function. What does that +3 do to it?
It's
a vertical, what is it?
Wait, what?
It's a vertical what?
Vertical shrink?
Shift.
Shift.
In other words, the vertical shifts. The shifts don't change the shape of the curve at all. The stretches did. In other words, a stretch changes the shape of the curve. It either makes it like that or it makes it like that, but it changes the shape. A vertical shift does only one thing. Moves it up or down. It either moves it up or moves it down. Does not change the shape. So make sure you remember the 3 words that are involved. We have stretch and shrink. Those both change the shape. And then we have shift, which either moves it up or down or right or left, depending on whether it's added to the function or part of the function. If it's added to the function, it's a vertical shift. What does a vertical shift of +3 do?
Does it make it -3?
No, it moves it straight up.
Oh.
In other words, there's 3. So now this parabola is going to look exactly the same. You could almost say it's parallel to this one. So there's my parabola, and that is what it is. And it matters whether you do the shift first or the reflection first. It's very important to do all of your reflections first. Notice the difference. It makes a difference. No, it doesn't. Here it doesn't make a difference. In other words, if I did my shift first, I would get that. And then if I did, oh, it does make a difference. Then if I reflected that, it would show down there. So if I did the shift first and then reflected, that's what I would get. And that's not what I want. I want the reflection first and then the shift, moving everything up so that the final curve rests above the x-axis there, not below it. Like if I did the shift first, it would matter. So always do your reflection first. Of the 6 possible translations that can be done, 2 of them are reflections. Just make sure you do both of those before you do any shifts, shrinks, or stretches. Or, yeah. All right.
Okay.
Julian, I'm sorry I got to run. I got an 8 o'clock that I'm 3 minutes late for.
Alright, it's alright.
Talk to you next time.
Alright, thank you.
Good week. Bye-bye.